Okay, so this question says an equilateral triangle and an isosceles triangle share a common side. What is the measure of angle ABC? So measure of angle ABC, let's just highlight that angle real quick, is going to be that angle there. Is everybody okay with that? Okay. So angle addition postulate says that we need to figure out what is this blue angle, and then we need to figure out what is that yellow angle. And if we're able to figure out those individually, we should be able to add them up to get ABC, right? Okay. So that being said, if I just focus on one of these triangles at a time, okay? Don't look at both of them together yet, but look at one at a time. Which one do you want to look at first?
CBD.
This one here?
Yeah.
So if I'm looking at that one there, okay, what kind of triangle is that? Equilaterals. And if it's equilateral, we had a corollary that said it is also isosceles, but furthermore, to tell me something about the angles, it's equiangular. So if it's equiangular, that means they're all the same angle, right? So they all have to be 60 degrees. Okay. Now, just because this one is 60 and it's across from a mark that has one slash, or a side that has one mark in it, one slash in it, does not mean that when I go over to this triangle that everything across from one mark in those triangles, in the second triangle, has to be 60 as well. Does that make sense? Okay. But if I look over in this second triangle, if those are the sides that have marks in it, that's an isosceles triangle now, right? What does this angle right here have to be? 67. Okay. So if that's 67, you have now used how many degrees for this triangle? What's 60 plus 60? 120. What's 7 plus 7? So you've used 134 degrees, right? What would be left over then? .46. Okay. So those are the individual values for the angle, or the angles, that collectively, using the angle addition postulate, add up to give me that blue angle, right? So what's that make angle ABC's measurement? .106, right? 46 plus 60. Does that make sense?
Yeah.
Okay. Other questions?
Actually, hold on. Number 5, I could figure out N, but I couldn't figure out N.
Okay, so M. Let me, it's easier for me to cut these out. And
You should make the angle 122 as B.
I'm not going to do your question for you.
That's not my question.
You liar.
That's someone else's question. We get 122.
All right, so how did you go about finding M?
I don't know. I didn't even do it.
That
I don't know. It's like supplement. The 110 is supplementary to like.
To this one.
that
All right, so this angle right here is a linear pair with 110, right? So that means they have to be 70 and 110.
That means plus 90.
Okay, so if we can look at it a couple different ways. If we look at just that triangle, we know that that is a triangle, so it has 180 degrees in it, right?
Yeah.
We've already used 90 and 70, so that's 160, leaving me with 20 for M, right?
Yeah.
Or you could use the corollary that we had of the triangle angle sum theorem that said if you're in a right triangle, which is what we're in, right? The two angles, the two acute angles are complementary. So if 170 to be complementary, they have to add up to 90, so the other one's 20, right? So I got M to be 20. Now, how do I find N? N. This angle right there.
M 35.
Yep, that's exactly how you do it. You take, let's see here.
What do you do? Wash it.
We all rush to the sun. It's bigger than my phone.
Okay, so if we ignore that right triangle that was here, does it become a little bit more obvious what we're going to do with this picture? If this is my vertex angle, right? Up top here, 120 or 110 degrees. So how many degrees do you have left over for the entire triangle? You have 70 left over. And what do you know about that angle there in comparison to that angle there that make up that remaining 70?
They're the same.
Why are they the same?
Because they're base angles.
Okay, so in an isosceles triangle, the base angles are congruent. So if they're the same, if I divide by 2, that tells me that each one of those angles is going to be 35. So then N is 35. All right, so 17 says the length of the base of an isosceles triangle is X. So let's say this is my base here. This is X. The length of a leg is 2x minus 4. What do you know about the legs of an isosceles triangle?
They're the same.
They're the same. So this one's got to be 2x minus 4 as well, right?
Yeah.
What's perimeter? Yeah, it's the sum of all three sides, right? So I'm going to take 2x minus 4 plus x plus 2x minus 4. And that should total 62. So I got 4, careful. Should be 5x's, right? So 5x minus 8 is equal to 62.
Minus 8 from that, and then divide by 5.
So how many times is 5 going to 70? 14. Okay. So this would be 14. This would be, what, 28 minus 4, so 24? That would be 24. If we add those together, we get 62.
Oh, yeah, that was definitely way easier than I thought.
19 and
Wow,
20.
why is it not loading?
Dude,
Oh.
I need a haircut, bro.
Now you're 14.
Yeah, I think you should go back to 19.
No,
We're going to do it with those ordered pairs of 4, 2, 10, -2, and -2, -2. Okay? Now, you can, by all means, graph this to organize your thoughts, to organize your work and what information that you have and what information you need. But it's none of the stuff here is a necessity for you to graph. Okay? But it says triangle ABC has those vertices. And it says find AB. So it wants to find the length of the segment from A to B. Okay? Now, we talked about this in section 1.8. About a week and a half ago, we had a question about this. It's the same thing again. Do you guys remember that the distance formula is found using x2 minus x1, that quantity squared, plus y2 minus y1, that quantity squared. Remember doing that? That's all this problem is. Okay, so if I'm going to do the distance of A and B. Okay, I don't care which one's x1, x2, y1, y2. All I'm going to do is I'm going to subtract the x's because that's what this is saying here. Subtract your x's. So I'm going to go 10 minus 4. 10 minus 4 will give me what? 6. And then we'll square that. And I'm going to add to that. I'm going to go either -2 minus 2 or 2 minus 2. -2. It doesn't matter the way you do the subtraction on the y's either. So what's 2 minus -2? Be 4, right? And I'm going to square that. So 6 squared is 36. 4 squared is 16. So that is going to give me radical 52. Okay? So that is the length then of A to B. Now we can put that into a decimal if we actually want to know where that is. But radical 52, 52 is a little bit bigger than 49, right? What's radical 49 the same as? 7. Okay? 52 is a little bit smaller than 64, right? What's the square root of 64? 8. So radical 52 is somewhere in between 7 and 8. Okay? Closer to 7 than it is to 8. Okay? So if you have interest of actually knowing the exact value, it's probably like 7.2-ish, 7.1-ish. Okay? Now, it doesn't matter, like I said, it doesn't matter the order that you did the subtraction because we're squaring. It's going to take, no matter whether that number right there becomes positive or negative, when you square it, it's going to become positive. Okay? So now I'm going to do the same thing for B and C. Okay, so working from B to C. Okay, now it's going to be, do this in a different color. Okay, if I subtract my x's, what's 10 minus negative 2? 12. And I'll square that. And now I'll take negative 2 minus negative 2. What's negative 2 minus negative 2? 0. And I'll square that. Okay? What that tells me right there is that this segment BC, because the y values were the same, this segment BC is actually horizontal. Okay? But then I get, what's 12 squared? 144. So that gives me a distance of 12. Okay, square root of 144. And then we'll do AC. So AC, you're going to subtract that x and that x. So what's 4 minus negative 2? 6. And you'll square that. Then you're going to add to it, what is 2 minus negative 2? That's 4. And you'll square that. So I get 36 plus 16 again, right? Radical 52. Okay. So you just found 3 distances, 3 sides of a triangle. One side was 52, one side was 12, and another side was radical 52. What does that tell you about this triangle? Triangles isosceles. That's what that information right there tells me. Okay? Now, trying to figure out the slope. Okay, we'll talk about why I'm trying to find slope here in a little bit. We talked about this at the end of chapter 3. The slope of AB. Okay, remember slope is y2 minus y1. So I'm going to go 2 minus negative 2, right? 2 minus negative 2. And we'll go 4 minus 10. Okay, so 2 minus negative 2 is 4. 4 minus 10 is negative 6. So we get negative 2/3, right? That's the slope of AB. The slope of BC would be negative 2 minus negative 2 over 10 minus negative 2. What's negative 2 minus negative 2? 0. Okay. Do I care then what the bottom is? I don't even need to do that math. It's 12, but I don't need to do that math because 0 divided by anything is 0. Okay. And then the last one, AC. I'm going to do a 2 minus negative 2 again. 2 minus negative 2 gives me 4. And then we'll go 4 minus negative 2, which gives me 6. So I get 2/3. Okay. Now, does anybody remember why I might be interested in determining the slopes? Let me real quick generate this question here. So this is the triangle we're talking about. And if we're in the XY plane, that is it there. Okay, if I have, what we just found out was the slope of that line right there was 2/3, and the slope of that line was negative 2/3. Those are the exact values that we came up with, and we also found the slope of that one to be 0. Is everybody okay with that? Okay. Do you ever remember why we might be interested in determining the slopes of lines in regards to being able to identify an angle or a feature about an angle? What do you get if you take negative 2/3 times positive 2/3? Get negative 4/9, right? When I multiply the slopes of two lines and they give me -1, which this does not do, this does not give me -1. You guys remember what it means if your slopes of two lines multiplied together give you -1? What would those two lines be to one another? Let's do it this way. What if I took, we'll go back to this triangle, but what if I took if I multiplied those, so that triangle has slopes that are +1 and -1. If I multiply them together, they give me -1. What is this angle right here? See how that angle is 90 degrees? And that's because these two lines were perpendicular, right? And they were perpendicular. I knew they were perpendicular by multiplying their slopes and getting -1. If I take those two and I multiply their slopes and I don't get -1, can I now say that I know that that is not a right angle? Does that make sense? Okay. So when we go down and we ask or are asked these final questions, the best way to identify this type of triangle, okay, we know it's not equilateral because we found two different distances, right? We found radical 52 and we found 12. So it's not equilateral. Is it isosceles? It is isosceles. So maybe we could say that right away. But then there are other options here. Okay, is it a right isosceles? Well, we just found the slopes that said no, it's not right. Okay? If it's isosceles, that is a complete contradiction to being scalene, so it can't be that. And we know it's not right. So it can't be that right isosceles with a right angle of B. So in this case, my only option is that it's isosceles. Does that kind of make sense? Okay. Says, if this is the case, okay, if it is isosceles, then which of these set of angles do you know being congruent from it being isosceles? So the two sides that were congruent, if you just draw a quick sketch of this, it might help. We've got A, B, and C. And AB we just said was radical 52. We said BC was 12. And AC was radical 52. So does that tell you that this side here and that side there are the congruent sides? So does that automatically tell you that B and C are the congruent angles? So for this question, we're going to come down here and say B is congruent to C. All right. And the last one says, what is the measurement of angle B? Okay. So I can't, based on the points that I chose in this example, I cannot determine that, okay? But if we go back and we look at this triangle, that question makes sense for this triangle. Because we know now that that angle up here, and I've got, it's the wrong, I guess it's okay. So this angle here, angle A, that would be 90 degrees, correct? Okay, and this triangle is isosceles, so as we were marking our questions off, we would have highlighted the option that says the right isosceles triangle, with angle A being the vertex angle in this case. And now how does that tell me what angle B and angle C are? If it's isosceles, B and C have to be the same, right? If it's a right triangle, then B and C can only add up to 90 degrees, correct? So what does B have to be? It has to be 45, okay? A 45, 45, 90 right triangle is one of the most important triangles of all, okay? There's a handful of very, very useful, very, very common triangles that exist that we use quite a bit. 45, 45, 90, 30, 60, 90, based off angles. Those are triangles that we like to focus with. Based off sides, we like to deal with the 3, 4, 5 triangle a lot with side lengths. Does that help answer a question like 19 or 20? All right, so again, just reiterating what I've said in the past. This coordinate plane work with distances and that sort of thing is going to become very prevalent as we move through the rest of the chapters, okay? Right now, it's probably maybe the third or fourth time it's popped up. It will pop up a lot, okay? If you're a person that has downloaded the notes, printed them off, you can start to see one section of those notes. There's a lot of stuff that deals with coordinate plane stuff, okay? So we're gonna get into that here pretty soon. Does anybody have any other questions on that assignment? 17. We already did that one. Yep.
What about number 16? I keep doing it, but I keep getting it wrong.
Find values of x and y here. What number do you have in this angle right here?
16.
Okay. So if we look at this one, you've got how many triangles do you have here?
2.
2. Are they? Is there anything special about them?
They're both isosceles.
They're both isosceles. Okay. Let's look at. Hey, it doesn't matter, I don't think, but let's look at this one here. It's a right triangle, correct?
Yeah.
Okay, and based off the discussion we just had in the last question, if that's y, what's that got to be? Y. And what do they both have to be then if this is a right isosceles triangle?
35.
Say again?
35.
Say it again?
35.
Say it again?
45.
45. Okay, so both got to be 45 degrees, right? Okay, so now x is talking about that angle there. Oh, sorry. That angle there. Does that make sense, everybody? Okay. Now, you have the ability to determine that angle. Because is that a base angle for the overall triangle?
Yeah.
Okay, so what's 180 minus 36? 144. Okay, so you have 144 degrees now left over for that angle and that angle. But what do you know about those two angles?
That half of it's 45.
No, not half.
Well,
If you know, just look at an isosceles triangle right now that has this to be 36. Do you know what this angle right here has to be? Because you just said 144 was going to be what's left over for that one and that one, right? And what do you know about those two compared to one another?
they're the same.
They're the same. Should be 72. 144 divided by 2, right? So if that's 72, so that means this angle right here, this blue angle or red angle now is 72 degrees, right? But don't you know that that is 45 of that 72? Does that make sense? So what can I do with 45 and 72 to get that angle right there? 45 and 72, what do I do with those two?
I'll subtract.
Subtract them, okay? So 72 minus 45 will give me that purple angle X. Yes?
I have another quick question about money. When you're looking to see, like,